went offline.
Yeah, it looks like I don't know why, but had some connectivity issues. But it looks like
Oh, it's back.
Now I'm just
I
getting an ad.
yeah, I guess it's like I'll take the opportunity to show you an ad.
Do you want
It's
to
back
do
now.
Yeah, it should be back. But we can also take a break. It's about time for that. And then when we get back, we can start working on the DOM file system.
Cool. Yeah, just before noon then.
Yeah. RB. So what is that? 12:03. We'll back for 10
Sure.
10-minute break.
Sure.
Okay. Cool. BRB. Okay, I'm back. I guess disconnecting is probably going to make VOD split into two. Maybe not. It'll be smart enough. Just a network hiccup.
Hello.
Welcome back.
Alright. Hello, can you hear like any background noises from my side?
Well, I've heard a little. I can't tell
Yeah,
what,
there's
but
just
some.
like it's just like outside my house they are doing some road work.
Oh yeah, yeah. It's not so bad.
Hmm.
Terabit should be back any minute.
Hmm.
Any questions, curiosity so far? Kind of laid a lot on this one.
Yeah, there was a lot, but it's just I was curious about like how the web connectivity was working.
Mm,
It was kind of confusing. Like we are making a VM on the web,
yeah,
and in that VM we are loading in the Wanix.
I'll explain that. Well, so Wanix is actually being loaded as a WebAssembly module.
Hmm.
I'm back.
WebAssembly, welcome back. We'll get started. I just wanted to explain the idea that it's not that we're running Wanix in a VM. We're actually running it in WebAssembly, which is almost VM-like technology, but it's basically, since I don't think we've talked about it, Rohit, but WebAssembly is,
Hmm.
it's sort of a compile target, so you can build in the same way that you can build an application for a different, architecture, ARM versus x86, as well as sometimes you might have a different build target like Windows versus Linux.
Hmm.
There is now a build target, a kind of an architecture called WebAssembly. And the idea is to let you run arbitrary kind of code, almost like machine code, in
Hmm.
the browser. That was the original idea. The idea was
Oh,
instead
wait. So
of
is it like
just being able to
Hmm.
have JavaScript, by
Yeah.
creating this generic executable host, then you can run other things in the browser. And technically, V86, the emulator that we've been using, is a
Hmm.
WebAssembly module itself. So it's working by running in WebAssembly. So there's actually two WebAssembly modules that we kind of saw on the page just now. One was for v86, the emulator, and then one was for Wanix. So Wanix was not running inside the emulator. Wanix is sort of running alongside it as another WebAssembly module. And then we bridge the two sort of with JavaScript. I can kind of show you.
Okay.
So, I mean, it's kind of hidden away, but when we create a v86 emulator, it's actually loading this WASM file into as a WASM module, and then configuring it with a bunch of JavaScript code around it. But at the core of v86, there is a WASM module. And then separately, we have a Wanix WASM module, or at least a special build of Wanix. If we look in here, the build for this, not only are we using TinyGo, we could use what people call Big Go, the standard Go compiler. It could compile to WASM as well, but it produces a much larger binary. In fact, let's try quick. So the Go's compiler is pretty great in that it can cross-compile to other platforms very easily. Most other traditional tool chains require either a lot of extra custom tooling, or that you somehow compile on the platform that you're compiling to. So this is great. Go, on a Mac, I can compile a Windows binary if I wanted to, and it doesn't require anything extra. So the process is very similar for targeting WASM. And we'll call this WASM. So Go just compiled this guy here. And it's basically based on this code that we'll kind of revisit again, but you can see that WASM file is about almost 8 megabytes. Because it basically doesn't it sort of includes the entire Go runtime, and there's a fair amount of runtime included in Go compared to C or some of these other system languages. Whereas TinyGo is able to sort of not include things that aren't used, and so the WASM file that TinyGo produces is actually 1 megabyte. So the exact same source code, but we use TinyGo to compile it, and we get, a 1/8 the size binary. That's why we're using TinyGo. And we could even, if we wanted to, compress that with like gzip or something, and it becomes, a third the size. So anyway, that's WebAssembly. And you can kind of think of a WASM file as like an executable or a shared library. It's binary code that can only be run by a WASM host. And there's a WASM host built into every browser now. And you can also run WASM natively as well. There's a Go WASM host. So WASM becomes a way to make little programs that can run anywhere, regardless of the underlying native platform, including in the web browser. And they're sort of entirely isolated. So they're like one use case for WebAssembly is Shopify, is a very popular e-commerce platform. And they used to use, like a lot of other sites, they used to use webhooks as a way to let you customize what happens when, I don't know what, like after a checkout happens or before a checkout happens, it can do a webhook to your server, and you can write custom code that runs on your server to, after a checkout, it will automatically email somebody or, put an entry in your database, whatever, these integrations that you need to do, these hooks. And so webhooks was, a way to do that. But there are problems with webhooks. One is the Shopify has to make a request out to your server, and who knows where that's running. It could be, running on your laptop and it's not always there, and maybe it's slow to respond. But at least the benefit is that code can be whatever you want because you're running it on your computer. Shopify doesn't have to worry about how that code might, used to somehow create use an exploit to get into the rest of the Shopify system, right? WASM introduces a new way to let users provide hooks or custom code on these kinds of events, because they can just say, upload your WASM file, which means it can be any language as long as it compiles to WASM. And then they can run that WASM in a host, which it's totally isolated. So you have to give it access to things. Otherwise, the code inside a WASM module can't touch anything on the outside. Kind of like the idea of containers, but even more lightweight. So anyway, that's part of the story of WASM. And Tara, I don't know how much you know about WASM, but maybe helpful for you as well.
Yeah, for sure. Just kind of what I've absorbed from you and Julian.
Oh yeah, because we're working with beginning. Okay, so that is the story behind WASM. Oh, so I guess some other interesting things is when we compile Go code to WASM, we get a special module, syscall.js. And it's syscall.js because it's kind of like, normally syscalls would be working with a kernel, but in this case, there is no kernel. But you do have sort of the JavaScript environment or the page that you're run on. So syscall.js is something that you can use when you compile Go to WASM to do a bunch of things like interacting with the page, mostly in you have first of all, there's an abstraction to work with JavaScript values, since they're sort of a little different than Go values. They're dynamic and all this stuff, so they're represented in Go as a value. And values have things like being able to cast it to the appropriate Go type. So if it's a Boolean, then we can call bool and it'll give us a Go bool. Same with float. If it's an object and we want to sort of access a property or a method on it, we can use get to give it a string of the property that we want to get, and it'll resolve it. So we can use JavaScript code from Go using this interface. And this global function gives us the equivalent of window, or sometimes it's global depending on the situation. But obviously window is sort of like the top level object in the JavaScript world in the browser. So from there you can get the document, you can get access to all of the stuff that the DOM provides through this global. So, and there's some other helpers in here, for example, copying bytes, kind of more low level data. There's some helpers to do that efficiently. There's some helpers to expose to create a JavaScript function out of a Go function. So for example, if you need to create a callback for what happens when you click a button, you can create a Go function that looks like this, where it's wrapped in JavaScript function of, and then you define a Go function. And then we can take that sort of JavaScript function and then pass that to any JavaScript API that needs a function. So here, this is like calling document.getElementById, and then passing it the name my button, and then on the return of that, we'll call add event listener for the click event, and then pass the callback. And so now that button, when you click it, will run this Go code. So that's kind of how API-wise Go interacts with JavaScript on a page. And so we're going to kind of use this to create a file system abstraction to do some stuff through the file system, which means that we would then be able to do it from, a Linux shell or anything like that once that's all set up. So I was going to create a new package, top level package in here called web. Put all the web specific stuff, because I do want this version of Wanix to be something that you could use outside of the web. So all the web stuff will have its own. Interacting with DOM. Yes, we'll call it. In which we'll basically create a file system very similar made here. They're proc or fn. Copy file system. And I'm just kind of sketching this out. I don't know a lot of the details other than that we're creating a file system, a sort of a Wanix device that is a file system. It won't need types, although, well, so let me kind of sketch this out, what I kind of, so, okay, DOM directory. I don't know entirely how this will be used, but I figure, there would be a built-in reference to the page body, and any sort of DOM element might have a file system that lets us do stuff like read or set its HTML, or it's like inner text. So you can imagine being able to write to DOM body text, and it will populate the contents of the of the body element with that text, or replace the body with this HTML. We can also use these to read the HTML, very similar to what you can do on the DOM, like document body. Outer HTML includes the actual body tags. Right, so this is the HTML that's on the page. So you can imagine reading and writing that through a file. Maybe attributes or something. This is all not exhaustive. I'm not trying to create something that'll let you do anything with the DOM, but just as an experiment to see what it might be like. I also wanted to be able to create new DOM elements. So we would have a new here. And I kind of maybe had the idea that you would specify maybe the tag. So instead of just new to create an element, you could say new div, new iframe. So that means that would we have to create, a directory for every possible HTML element? I didn't really want to do that. But maybe there are at least certain ones that are useful to create in this scenario. For example, iframe is one that we're going to use a lot. And maybe we even just make these registerable things, so they don't even need to be a one-to-one mapping to the elements that you have by default, but we could also do stuff like instantiate an xterm thing, and that's not really an HTML element that's built into HTML, but there is a library, xterm.js, that's used to create this terminal. This is, but same with the terminal here as well. Xterm.js is pretty standard for creating these terminals, and it's a JavaScript library, and so we could just maybe make it a new type of thing that we can create on the DOM. And similar to these other systems, I guess, is when you make them, they will have kind of numeric ID that don't necessarily correspond to anything in DOM, that are just IDs to reference them. Wanix. If I created a new div, then it would create maybe there's a control file, and maybe the control file can take various methods that you might call on the DOM. Entirely sure yet. We know though that we want to be able to create an xterm thing. So I kind of like this idea that this is sort of a gateway to the DOM for Wanix, but isn't sort of just a raw representation of the DOM. It won't let you create any kind of element, but only the ones that we register. And once we register them, they can have custom file systems. Maybe if this one is, this were xterm, then it would have some other custom stuff in here like data. So yeah, thinking out loud here. So that means that we would have maybe some types that we would register. It might come with div and then iframe. And xterm would be one where we would also load in the xterm library. Yeah, we'll pretty much need the same stuff as the other devices that we've made. We'll have a register, open and open context, implement file system. I don't think we need a control node for the DOM. Maybe at some point when there's something that we want to do, some API we want to expose, we do that through control node. There's so many ways we could go with this because we're basically creating a new API on top of the DOM. Which is why I'm trying to focus on just the things that we're trying to accomplish so that, this is ultimately an experiment, and maybe in a year, this DOM device looks totally different. I don't know. So we won't have a control. We will have a new that works pretty much the same as these other ones. It's going to list whatever registered types under new. If we read it, it's going to allocate a new resource, and then we list the resources. So these resources might be different though. We can so if we wanted to create a new div, normally I don't have to find an example, but like create a new DOM element body. Normally this is what you would do in JavaScript. You create an element and then you have it as a variable. You set its attributes or whatever. And then you have to kind of attach it to something in the DOM, like to the body. So that's kind of what I'm thinking here, is that when you do a new, it's effectively creating, element in memory that you can reference. It's not attached to anything. It won't show up until you attach it. So I'm wondering how we would do that attaching. Maybe it is just body as a control node in which you send a message like append and then point to the path to some thing that we created, and that would effectively call append child. I guess it could be nice to child node. You don't really need that far. So every element control node for doing DOMs. Even though it is a resource in the sense that we are creating these resource managing file systems, language that's a little bit more concrete to the domain that we're modeling. And you can imagine this would have a reference to a JavaScript value that points to that. That's the actual reference to the element that we're creating. So already probably a good idea to the top. This is a Go, kind of like a macro. It's a directive that basically tells the Go compiler not to build this unless it has one of these build tags. So in the case of compiling to JavaScript and WASM, if we were to compile to Apple or Windows or something like that, this code would just not be compiled. But we want, because there's no DOM in those environments and we wouldn't have syscall.js. So let's actually do some JavaScript in here. Document, create element. So we do need to reference document. I think we would do all to do. And then the tag name of this file. So if we're saying new div or new iframe, good. Oh, it's global, not. And yeah, what we could do just to test this out is we could do HTML, thing that would return the outer HTML. Value, and then I think, or is outer HTML is a property. It's not actually a function that we also get, and that's going to return a JavaScript value. And this field file utility that we make does let us specify a setter. So later on, we could do something so that when we write to the HTML file, it sets the outer HTML. We'll just hit this. So let's see. Where to register div. This should create a div iframe. Now let's go back. WASM scenario, and we're gonna do this. I don't know that DOM would be. It makes sense to try and make DOM built into the kernel when you compile to WebAssembly. The only way we could do that is we could have different declarations of this file for different build targets. But I'm wondering if that's what we want to do, if there's a better way to organize it. But for now, we'll just do that. Create another file called build tag. Make it kind of use endings. This one will only be used if we're compiling to WASM. Say if so now we have two versions of kernel. We'll have duplication for now, but say DOM device. So we can register a couple. If we're not really using these factory initializers. It's an empty. Oh, sorry, the div. So this will, in theory, have div show up as a type of DOM element we could create underneath. Yeah, what else? Element, but it won't attach it to the body yet, but at least we can allocate it and see what the HTML is in theory. Hopefully outer HTML would be. So let's now, I guess. So this is it. There's going to be a, let me comment. Have the emulator there. We're just going to, oh yeah, how will we interact with it? Okay, so we have readdir, so maybe that's a no. I would have expected DOM to be in. Let's see. We have a Wanix thing. Okay. What is missing? Maybe it didn't actually. Oh. No, that should create a new kernel. Oh, maybe it's hidden file. It in here. Okay. So just because we created this DOM device in this struct, we haven't made it available as a hidden device or anything else. So I guess DOM and unhide it. Now we should see DOM. Building it. Okay, so there's DOM. It's calling readdir, I think. Yeah, I don't know why. I guess I made it so after the WebAssembly loads, it calls dir dot. So that's why we're getting this every time. So that's kind of helpful just to see the state of things. But yeah, so now we can dir DOM. What's in DOM? New. Give an iframe. Well, that's cool. I don't have a read file yet, I don't think. We'll have to create a couple more. Helper file. Write file. I have readdir. That's about everything that we would need to kind of work with it. Write file. One file mode. So these are the what you'd call in JavaScript, and then they're going to call over duplex. So now we have to expose those duplex. Learn one for read file. For now, we're like debugging, printing when it's called and what the args are. That's actually bytes, all namespace with args, error, return the error. Otherwise, we're going to return bytes of the file. Write file. Oh, it also is going to have the bytes to write and the although these are all set up as strings, so I will any and then type assert the hopefully this one. Int of some kind, cast to guess what's wrong now. Oh, there's no bytes that are so I would just turn any. All right, write file. And all the work of that we've already implemented with these helpers. So kind of exposing the but that's that would that'll want a uint. Oh, we'll get to write file later. Let's see, we changed the Go file, so we need to recompile. Serve will recompile, then serve. Sure. Oh, no. Oh, yeah. What do we have? Give an iframe. Someone's phone's vibrating. Oh, we want file. Ooh. Interesting. I don't know what's causing that. But I'm going to ignore that for now because it did give us something over here. Oh, it's going to say it every time, maybe? Read dir. So now if we do a read file on type. Okay, so it's giving us a byte, a uint8 array, so it's a little hard to read for debugging purposes. And I guess we're getting this for every operation. I don't know why. We'll probably have to take care of it just to make it stop being so annoying. But just as a quick test here, if we do HTML, now that array and oh, it's hard to convert these to a string. We have to create a text decoder. Think and code bytes. That's the HTML for the iframe that we made. That came from the DOM. So far things are working, except for the parts that aren't. What do you want to do next, Rohit? You want to look into this? I think we should look into this.
I mean, I can.
Not you, but I mean,
Like
on the stream. Should we look into this, or should we ignore that and kind of keep going?
Do we know what like the issue? What's the causing that issue?
Nope, I have no idea.
Oh.
But it's interesting that we're getting those errors and then we get a result, so we're not sort of blocked by it, but it is kind of annoying. Yara, what do you think? Should we look into this?
Yes, I think you should.
Okay.
I don't like
Can we-
seeing errors.
Can we add like some console logs that might help us narrow it
Yeah,
down?
well, I was going to say, we know that it's coming from this WASM exec, which is the bridge code for Go, WASM, and JavaScript that helps kind of make the WASM stuff work. So let's look just to kind of get an idea. TinyGo does not support finalers, so this should never be called. Interesting. Finalize ref. I'm guessing that the code in this syscall.js is using finalizers. Let me see if I can prove that. Let's see, what code did that happens after the Go code logs it. Get a little bit of a stack trace. Open DOM element. Know that it's related to this code. Maybe it has to do with this. I guess one thing we could do is if don't get it. Finalizers is a feature of Go that lets you, when the garbage collector decides to clean up some data, you can have a finalizer associated with that value to help clean it up. It's kind of an advanced feature, and I can imagine that it's useful when you're sort of holding references to things in another system. So in Go, you have a value, and that's a reference to a value in JavaScript. But JavaScript has its own sort of garbage collector and everything. So oftentimes when you bridge stuff into Go or any other system where you have a reference to something in another system, that you would, when the Go garbage collector cleans it up, it would do something to help clean it up in the other. So it's kind of has to do with like bridging two systems. That's sort of my guess. Okay, so it's compiled. And I don't remember if we saw it like but it looks like it's not. Yeah, I feel like it was doing it after all of these. So it does seem to be associated with calling get, maybe a string. Could we could use the control node to send some bit. Make up some things that we can pass to the control node to run some code to see what. So HTML. We won't assign that or anything. We'll just run it to see that does it. It could also be maybe something that's specific to calling string. Make another version. This is, just kind of bug code. That way, we're doing this on the control file just so we can like manually trigger something that will cause these two things, so we can kind of isolate what's going on. Create an iframe. Oh, and we haven't tested write file yet. I don't even know if that works, but let's try it. Wanix file. Oh, and it's gonna. Okay, quick. We have to make this new text. Stupid thing about JavaScript. So if we wanted to make a string become a uint8 array of bytes, we have to use that. So now Wanix write to file to a code. And I don't think the file mode matters. I should have just not specified, but now it's gonna. What? Oh, it's. Okay. So this has to do with our write file implement. Not a super useful stack trace. I'm a little surprised. Unreachable. Assert. Seems like it has something to do with the asserts. I'm going to just hard code a file mode. And then hopefully it's not an issue of this. I'm not sure how bytes should be serialized. So in theory, I guess I'll, normally if you do a type assertion, you should like check to see if it actually works instead of just doing it like that. Because it will panic if it can't. So we'll string. If it's not okay, then I guess we'll panic anyway, but we'll at least say that 0 is not a string. And then
It is currently 1 o'clock, just a heads up.
all right, let's see what would be a good stopping. We could get, feel like if we could go a little bit further if you guys are able to, and just try and get it to a point where we can get it to get to a point where we can create a DOM element and then append it to the body. And so then that would make it show up on the page. I think that would be good.
How long do you think?
Well, as long as we can resolve this, which I'm hoping we can pretty quickly. This.
Well, I can stay like 15 minutes.
Okay, let's say 50. And then simplify this. Coder. Permission denied. Wow, that's a little better. That is very interesting. We don't have something somewhere. Right permissions on here. Fortunately, the reader stuff that I made doesn't actually list like what the file permissions are. But it could just be I guess this will probably take more to debug, but we got pretty close. We made a DOM device that actually does kind of bridge DOM a little bit. We can at least like read. All right. Anyway, now we have like a bunch of things. We have to fix this. We have to figure out how to fix the finalizer thing that's happening with this. But yeah, all that I'm sure will be done by the next stream because I can't really help it but work on the outside of the stream, especially the stuff that feels like it's gonna be long and boring. Bug. But logistically, this Wednesday I'm going to MagFest, East Coast, until next Monday. So, and I think I'll check. That means that I actually wouldn't do a stream today either. So I think we only have one more stream this month for Wanix, which would be on the 29th. But yeah, so this will be it for a little while.
You think you'll work on Wanix while you're away?
I don't know if I'll work on it. I mean, I might, but
or just before or after.
Yeah, maybe before or after. So there will probably be. We'll probably have these problems resolved by the 29th.
Cool.
But yeah, so then we would have a working kind of a DOM device, which is now the first time this version of Wanix is sort of letting us interface with, the page that it's embedded on. And then from that, we can do the terminal, and then eventually we'll do the VM device, and to get to a point where we can do for real the version, the paper prototype that I showed here.
Exciting.
Yeah. Alrighty, and the music's over too, so our time is up.
Got played off.
Yep. All right. Thanks for hanging, everybody. And thanks, Tara and Rohit, for shadowing.
Thank you.
Thank you.
All right. Later.
Bye.
Bye.